Hello everybody, this is Cap here, and I would like to welcome you to the fourth video in my C++ containers tutorial series. And in this video we are going to start talking about vectors. And the main things I want to get through on this video are, of course, how to create a vector, how it acts in memory, and how to access members of vector. So, as you can see here, the first thing you need to do, of course, is include vector, and then you create a vector by typing in vector, of course, and then a less than sign, the data type that you want the vector to store, and then the greater than sign, and then a name for your vector. So what I'm doing here is I'm printing out the address of the vector so that we can look at it in memory. So I'm just going to step into this here. And move that over there. Okay, now I have the address, so let's go look at it. Okay, so what we're going to be concerned with here are these three rows. So each of these are pointers. So one is the beginning pointer, another is the end pointer, and the capacity pointer. So, these are basically how the vector manages the vector data, or the part that we're concerned with anyways. And that's a kind of an issue most of the time when people try to understand vectors, is that the vector itself is not the data. There's the vector, and then there's the vector data. And you'll see what I'm talking about here in a minute when we start actually adding data here. So let's stop debugging, and first, for instance here, for a parameter, we're going to tell it we're going to put in, or start with 3 integers, so it will give us space to put at least 3 integers, maybe a little more for capacity. And then we are going to change these. Just like an array, you can access it with index or by index, and put 3, and okay, and then we are going to do some pushbacks. And basically, pushback just pushes a value onto the end of the vector data. So we're going to say v.pushback, and then in parentheses here we put the value that we want to be pushed onto the vector, and I'm going to say 7. I'm going to do another pushback, put 9, and I think that should probably do. So let's save it and then step into it again. Okay, let's find our vector. Okay, now as you can see, these are no longer set to all zeros anymore. So using these pointers, we can actually find the data that our vector is, I guess you'd say the data our vector is managing. So we have 0, 0, 5, 7, C7, and 0, 0. Okay, there we go. So here we have our space that has been, allocated and initialized for our 3 integers that we're told that we're going to put there. So as we go through here, you'll see these change to the values 3, 4, and 5. But if you'll notice something, these two here, these are our end and capacity pointers, which are set to the same address, which means that once it gets to here, it is going to have to actually allocate new space in memory somewhere else, copy all the data we put in here over to that space, and then free this up, which you'll see happen. So let's move through it here. So that changed it to 3, 4, 5. Now in the next turn, you're going to see a whole bunch of red going on, and then we'll explain it. There we go. So you're probably thinking, well, where'd it go? Well, all this was freed up, and then all of our vector data was moved somewhere else because we had reached capacity. So it was moved to this, wherever this beginner pointer is pointing to. So let's go find it again. Okay, there it is, and as you can see, 7 is now added onto there because of the pushback, which is, I guess you could say, the straw that broke the camel's back and caused the entire array data have to be moved somewhere else because it went past capacity. And as you can see, it did the exact same thing. Our capacity is still equal to our end. So that means if we try to push this on, it's going to have to move it all again. So let's do that. And there you go. So when we're working with integers and built-in data types like that, this isn't really that big of a deal. They're only 4 bytes. It's not that big of a deal to move them all in memory. But if we have, huge objects or anything like that, then this can really become a problem. And it can be, a little more taxing on the system than people may think. So vectors aren't just, a magical container that you can just push stuff onto and get no penalty for. So that's kind of the main thing I wanted to kind of get across, is how it works in memory in this video. And in the next video, we're going to go through how we can kind of manage this. But for the remainder of this video, let's go through another constructor and the at method. So let's get rid of that. And let's leave that at 3, but if we add another parameter here, and let's just say 5, it will create 3 integers with the value of 5 and put them in our vector data. So we create a for loop here. And have it print them out. Oops. So you can see you can do it pretty much just like our arrays. So let's run it. And as you can see, as I said, it created 3 integers and set them to 5. this is actually the unsafe way to access member or elements. There is another way using the @ method, like so. Save it and then run it. As you can see, we get the same result, but it's safer because this checks for out of bounds. So if you try to access something that's, not actually in your vector, then instead of, assigning some, strange value of whatever is actually in that memory spot, or sometimes crashing your program, it will throw an exception that you can then handle. So that's something to be aware of. And I think that that's pretty much all I really wanted to cover in this video. If you've seen my video on arrays, or videos on arrays, then you know all about the indexing and all that stuff. So if you guys like this video, please let me know by hitting the like button. If you've seen a few of my videos and really like them, go ahead and subscribe so you can see when I post new ones. And I would like to thank you for watching, and I will see you guys in the next video.